Hi, everybody. This is the lecture for April 19th, 2023. It covers locating a centroid by direct integration for statics, ES 2110. Those of you that were in class notice that I'm re-recording this lecture. And the reason is I wanted to eliminate an arithmetic mistake I had made, and also to clean up my work so that it would be easier to follow. So having said that, I'm working on section 5.2. This is in the 11th edition of our textbook, and the problem number is 536. So with that, I'm going to go ahead and make a note of something. First of all, if you take a look at our statics Moodle page, which I'll show you in just a second here. All right, what you'll see is I have lecture notes for Wednesday, April 19th, right there. And those lecture notes will be used in conjunction with this lecture so that you will be able to work the problem and follow along, and then use that material for future courses that are for future work that you do as well. All right, I had to stop the recording for a moment because some of my software wasn't working. But what I want to do then is to take a look at the lecture notes and go through this process with you. All right, so this is the problem that we were discussing, problem 5-36, and it's locating a centroid by direct integration. So basically what we have is a parabolic spandrel, which follows the equation y is equal to kx squared. And we are not using the centroid. We're not looking for the centroid of the entire spandrel. We're just looking for it for the portion that begins at x equals a and ends at x equals 2a. So what I've done here is drawn the spandrel, put in the equation. I've solved for the k value of that parabola, which I plug in the condition of this point right here, which is x is equal to 2a and y is equal to h. So plugging those values in, I get that the value of k is h over 4a squared, so that the equation can be written in a more specific fashion. Instead of writing y is equal to kx squared, you can substitute that in and get y is equal to hx squared over 4a squared. All right. So there are basically 5 steps to finding the centroid location, and I am using this point here at the very beginning of the first part of the spandrel, which is not part of our work, but I'm using this point as being my 0, 0. So everything is referenced from there. So after I draw the spandrel itself and I label it, I put in the element that I choose to use, which in this case is a dx times y element. In the work in class, I had suggested changing the element for one of the q values, and it turned out to be just kind of a big mess. So I would recommend just leaving the element look like this, a vertical element, for the work that we're going to do here. All right, so there's 5 things that you have to find. You have to find the area under that portion of the spandrel. Then you have to find q sub x, which is the first moment about the x-axis, the q sub y, which is the first moment about the y-axis, and then you divide q sub x by a to find y bar, the y coordinate of the centroid of the portion of the spandrel that we're interested in, and take q sub y divided by a to get the x component of that spandrel. So the first thing we do, the x component of the center of that spandrel. So the first thing that we do is we find the area. The area is equal to the integral of dA, which the way I have this drawn is a y dx element. So I add the limits because we go from here to here. The limits of the integral are from a to 2a. I plug in the values for that k value, h over 4a squared, which are all constants, so they come outside of the integral. So I'm just integrating x squared dx from a to 2a. And when I perform that operation, I come out with A, or the area underneath the spandrel, from x is equal to A to x is equal to 2A. The area is 7h times A over 12. All right, so the next thing I want to do is find q sub x. Q sub x is defined as being y to the element dA. So y to the element times dA, which is y dx. Y to the element, if you look at this, what y element means is y to the centroid of this element. Because it's a rectangle, it's at y over 2. So y to the element is y over 2. The area is just y dx. So I simplify that a little bit. Still, my limits are from A to 2A. Pull out the constant, put in the literal value of the k value of the k constant. Go ahead and perform this integration. We have to square everything in here. So we do have some other constant terms. We square h to get h squared. We square 4 to get 16. We square a squared to get a to the 4th. So we can pull all of that stuff outside of the integral along with the 1/2. And we're left with x to the 4th dx inside the integral. So we integrate that from a to 2a, and we go through the work, and we come up with a value of x q sub x is equal to 31h squared a over 160. Now, right here, my pen started to die, so it's the same. There's nothing special about this. It's just a different pen. All right, now I know that y bar, the y coordinate of the centroid, is equal to q sub x divided by the area. So I put q sub x divided by the area. Since the area is a fraction, I can invert and multiply. Go ahead and simplify, and I get that the y coordinate of the centroid is 93h over 280. Now, something to notice is you would expect it to be in terms of h, not in terms of a, because h is the distance on the y-axis or in the y direction. Similarly, when we find x bar, we would expect it to be in terms of a, not in terms of h. All right, so I found my y coordinate of the centroid. So I do the same thing for the q sub y, which is equal to x dA. Here we have x to the element times y dx, which is dA, of course. Now go back, think about this. When we had y to the element, it was at y over 2. X to the element is just x, because for y to the element, we have this rectangle, and we're just going to the center, which is at y over 2. However, here, x to the element is just x. That element is infinitesimally narrow, so one side to the other, although it seems odd, has no actual distance. So x to the element is just x to the element. All right, so I plug that in, and I get x times y dx. So I plug in for y, I plug in the function for that. Then I go ahead and pull out the constants, integrate from a to 2a, and I come up with q sub y is equal to 15h a squared over 16. Then using the same idea, x bar is equal to q sub y over a. So I have q sub y. Instead of dividing by, I multiply by the reciprocal of the area, simplify, and I come out with a value of x bar, the x coordinate of the centroid, is equal to 45a over 28. Therefore, for an answer, because it asks me for the coordinates of the centroid, x bar, y bar is equal to the x bar value, 45a over 28, comma, the y bar value, 93h over 280. All right, so that's a lot cleaner than the work we did in class. So I wanted to make sure to have a clean version of what we had done for you. And then in class, I had also talked a little bit about our schedule for the rest of the semester. So I would just like to tag that information on. Take a look at our Moodle page. And what you'll see is that we have finished chapters 6, 7, and 8, and you have written your quiz. So I will grade that this afternoon and post your grades. Then we went back to chapter 5 and began working on that. The homework for chapter 5 is due April 26th, which is next week. Then we will do just a little bit of chapter 9, and you'll submit that homework by May 5th. And then we have our final exam schedule. Now, this final exam schedule was for last semester, the fall semester. So I'll update this and give you some dates. You can take your final exam during the final exam period for this class, which is scheduled for Wednesday of finals week at 11:30 in the morning, or you can take it in 2 1-hour blocks, or you can take it at another time that you make arrangements with me. I always leave the space open on the last day of finals week from 3 to 5, just in case somebody hasn't had a chance to do anything until that point. If things get messy in their lives, kind of gives you that last chance, Hail Mary, to get that finished and get it off your table for the end of the semester. So I will, like I said, basically my basic message is you'll have several opportunities to take the final, but if it's not in a pre-prescribed time that will be posted soon, you will be required to let me know ahead of time. And I'll put that up on this page. I'll put this up on our Moodle page underneath the block that says final exam. The dates will be changed and the times that you will be able to take your exam, and whether they're by Zoom or face-to-face or either, will also be displayed right there. But the other piece of information is that's only about 3 weeks away. So we're really moving toward it. All right, so that's it for today. If you have any questions, please let me know. I'm not going anywhere for the rest of the semester, so I'll be available almost all of the time. And whatever you need help with, let me know and I'll get you squared away. Have a great day.